We propose Level-S2fM, a novel neural incremental structure from motion approach. Different from the traditional structure from motion approaches, our Level-S2fM incrementally recover the camera poses and scene geometry from a set of uncalibrated images, while learning coordinate MLPs for the implicit surfaces and the radiance fields from the keypoint correspondences. As the most fundamental problem in image-based 3D reconstruction, structure from motion aims at estimating the camera poses and sparse point cloud of scenes from putative feature correspondences. Due to the independent nature of sparse point cloud that are from the tracked keypoint correspondences in a bottom-up fashion, the current SFM solutions are suffering from inevitable correspondence outliers. Recently, the success of neural radiance field, NeRF, inspire us to represent a scene geometry in coordinate MLPs, which is actually a unified and global representation of multi-view information. The recently emerged neural field representation has been used in dense reconstruction and novel view synthesis. However, they require to first estimate camera poses by using traditional SFM approaches such as ColMap. Such a de facto scenario led up to a great opportunity to rethink the relationship between neural fields and structure from motion. On the one hand, it is of great importance to explore the problem of neural fields optimization without knowing camera poses. On the other hand, if the perfect properties of neural field can facilitate the camera poses estimation is an open question to be answered. To optimize the NeRF with uncount poses, BARF took the first step, which joint optimizes the camera poses and NeRF under the supervision of rendering loss. However, due to inadequate supervision, BARF usually needs a relatively good pose initialization from ColMap. Instead of refining camera poses that are initialized by existing SFM systems, in this paper, we will renew the traditional incremental SFM pipelines from the perspective of neural fields. For this unexplored problem, because the incremental structure from motion pipeline first takes a pair of views as initialization and then incrementally registers new views, the few view configurations will frequently occur in the pipeline. Therefore, the challenges should be addressed, including two-view initialization and few-view optimization of neural fields, as well as new camera registration and joint optimization of implicit fields, such as sign distance functions and camera poses. Unlike traditional SFM approaches, the neural SFM should be defined on the neural implicit surfaces to recover the implicit surfaces and camera poses together. To achieve those goals, we proposed a novel approach, Level-S2fM, including 3 key points. First, we manage 2D image matches by implicit surfaces in coordinate MLPs. Second, our method simultaneously computes camera poses and implicit fields on the fly. Last, we present a neural bundle adjustment that optimizes the scene geometry and camera poses on implicit surfaces. In our method, the first important component is the SDF-based triangulation. We use the sphere tracing algorithm to query the 3D points in the images and use the 2D correspondences to supervise the training. Meanwhile, thanks to the powerful fitting capacity of the neural network, the SDF will interpolate a continuous surface from the max number of in-layer matches. Therefore, incorrect matches can be easily detected and rejected. To better constrain the SDF, we discovered that the incoherent consistency between the rendering depth and sphere tracing depth can help the SDF learning. As the figure shows, the depth consistency can help the sphere tracing better converge onto the surface. For the new camera registration, we first use the PNP from the 2D matches for pose initialization, and then refine the camera poses with the rendering guidance. For the joint adjustment of camera poses and SDF, we proposed neural bundle adjustment, which iteratively adjusts the SDF and camera poses via feature tracks while updating the 3D point set. The whole pipeline of Level-S2fM sequentially includes two-view initialization, new camera registration and refinement, local neural bundle adjustment, and global bundle adjustment and looping, beginning with new camera registration. Please check out our paper and GitHub repo for further details. Next are our experimental results. Our method improves the pose accuracy in blended MVS compared to our baseline ColMap. For further evaluation, we use our poses and ColMap poses to train an instant NGP, where our poses result in better novel view synthesis results. Here are some of our qualitative results for both small, middle, and large-scale scenes. The geometry is extraction and refused from our trained SDF for better illustration. Under the global regularization of the neural level sets, our method can better manage the 3D points with feature tracks, averaging the errors and rejecting the outliers. Here, the red points are ours, and the green ones are from Colmap. With the assistance of a simple coordinate MLP, our method achieves comparable and even better performance than Colmap without any engineering optimization and tricks for implementation. Thanks for your watching. Please move to our repo or website for more details and further exploration.